Section 7.4, Double Angle and Half Angle Identities. In this section, we are obviously going to be reviewing the double angle and half angle identities that you should have learned in your trig class. Also included in this section, although they are not in the title, you will see the product to sum and the sum to product identities. Okay, so it should be a lot of review for you. Okay, we are going to start with the double angle identities. Okay, and then we will proceed with the others. All right, so first of all, let's review what a double angle is. Okay, so a double angle is basically 2 times an angle. So for example, in whatever expression or equation you're working with, you might see something like this, 2 times theta. Okay, so if you have an angle theta, you are basically taking that angle, whatever its measure is, and you're doubling it. So you're multiplying it by 2. So for example, like I said, in whatever expression or equation you're working with, you might see the sine of 2 theta. You might see the cosine of 2 theta. You might see the tangent of 2 theta, and so on. Okay, so what I need you to do is realize that it's the angle that's being doubled. Okay, so if you see this expression, I'll take the sine of 2 theta first. Okay, what that would mean if you followed the order of operations, you would take your theta value, your angle, okay, and you would double it and multiply it by 2. That's going to give you a new angle. And then once you have that new angle, then you would be taking its sine. Okay, this is not the same thing as 2 times the sine of theta, where you're taking the sine of theta and then multiplying that result by 2. Okay, so you've got to be clear that you understand that it is some angle theta that is first being doubled or multiplied by 2, and then you're going to take the trigonometric function of that new angle. Okay, all right, so the double angle formulas are listed in a box below. Okay, so here instead of theta, I'm using A for the original angle. But notice in each of these, we are doubling the angle A. Okay, so that is how you can recognize that you are working with a double angle formula. Okay, so I am going to read through these, okay, and then we are going to derive them. Okay, so the first double angle formula is about sine. Okay, so the sine of 2A is equal to the 2 times the sine of A times the cosine of A. And then if you notice, equations 2, 3, and 4 are all different, but each one is a formula for the cosine of 2A. So there are 3 different double angle formulas for cosine. Okay, which one do you use? We'll talk about that as we get into this. Okay, it basically, the answer is going to be whichever one suits your needs the best at the particular time. Okay, so the first double angle formula for the cosine of 2A, that is going to be equal to the cosine squared of A minus sine squared of A. And then number 3, another formula for cosine of 2A is going to be 1 minus 2 times the sine squared of A. And then the third double angle formula for cosine, which is the 4th equation here overall, cosine of 2A is equal to 2 cosine squared A minus 1. Okay, and then the last double angle formula in number 5 here, it's the double angle formula for the tangent. Okay, so tangent of 2A is equal to it's equal to 2 times the tangent of A all over 1 minus the tangent squared of A. Okay, so again, make sure you recognize when you're working with a double angle formula, you see that the argument is 2 times A or 2 times theta or 2 times X, whatever your original angle is. Okay, and something else to notice is that when you look at the right hand sides of these equations, okay, the argument is just the angle A itself. Okay, so what this double angle formula does, okay, you start with a double angle on the left, and then on the right side of the equation, you don't have a double angle. It's just the original angle A. Okay, so keep that in mind. All right, like I said, these are pretty useful and you may use them pretty often. So I'm gonna show you where they come from. So if we go below the box here, it says the sum and difference formulas and the Pythagorean identities can be used to derive these double angle formulas. Okay, so we're going to walk through the process. So the first thing I'm going to derive is the first equation where the sine of 2a, where that equation comes from. Okay, so here we go. If I have the sine of 2a, okay, what this is equivalent to, this is the sine of the angle 2a. I'm going to rewrite it as a plus a. Okay, because a plus a is the same thing as 2 times a. And then I end up with the sine of something plus something. So I can use the sum formula or the sum identity for sine. Okay, so if I apply the sum identity for sine, I'm going to get the following. This is going to be the sine of a times the cosine of a plus the cosine of a times the sine of a. Okay, the arguments here are both a, so it may be a little confusing. But remember, I'll put in red here, what I'm using here is the fact that the sine of a plus b is equal to the sine of a times the cosine of b plus the cosine of a times the sine of b. Okay, so that's the original formula we reviewed in the last section. And here I'm applying that, but both of the arguments are a instead of a and b. Okay, all right, so at this point, I actually have the same thing on either side of the plus sign. Okay, if I look to the left of the plus sign, I have sine a times the cosine of a. On the other side of the plus sign, I have cosine a times the sine of a, but when you multiply, you can multiply in either order. So I can do a switcheroo right here. This is equivalent to the sine of a times the cosine of a, and now I have an exact match on either side of the plus sign. Okay, on both sides I have sine a times cosine of a, so I have one sine a cosine a here and another sine a cosine a here, so I have a total of 2 of them. Okay, so this turns into 2 times the sine of a times the cosine of a, and that is exactly the right hand side of the equation in the first double angle identity. Okay, we just showed that the sine of 2 times a is equal to 2 times the sine of a times the cosine of a. Okay, we started here and we ended up here. Okay, so that's the proof of the first one. So now we're going to move on and derive the second double angle formula, okay, which is the first double angle formula for cosine. Okay, so we're going to prove that the cosine of 2 times a is equal to the cosine squared of a minus the sine squared of a. Okay, so to do this, we're going to start off very similarly to the first derivation. If I'm looking to derive the cosine of 2 times a, this is the same thing as the cosine of a plus a. Okay, 2a is the same thing as a plus a. So now I'm going to apply the sum formula for cosine. Okay, so if you recall what that is, I'll write it here in red. Okay, the cosine of a plus b is equal to the cosine of a times the cosine of b minus the cosine, minus the sine, minus the sine of a times the sine of b. Okay, so we just did that in the last section. Okay, I'm going to apply this to the cosine of a plus a. So here, instead of having arguments a and b, both of the arguments are going to be a. Okay, so I'm going to get the cosine of a times the cosine of a minus the sine of a times the sine of a. All right, so When I look at this, okay, I've got different things on either side of the minus sign, but I can do some combining. Okay, if I go back and look what I've ended up with, cosine A times cosine A, that's the same thing as cosine squared of A, because I'm multiplying the cosine of A by itself. And then I've got my subtraction sign. I'm subtracting sine A times sine A. I'm multiplying sine A by itself, so that's sine squared A. And we are done. We have proved the second double angle identity. Okay, if you come back up here, we proved that the cosine of 2A is indeed equal to the cosine squared of A minus the sine squared of A. Okay, this equals this. Okay, so we are done. Okay, moving on to the top of page 2. So now I'm going to show you where formula number 3 comes from. Okay, so if we go back to the box, this is going to be another double angle formula for the cosine. All right, so I'm going to show you that cosine of 2A is equal to 1 minus 2 times the sine squared of A. Okay, so I'm going to go to page 2, and I'm actually just going to write down what the formula is that we're trying to prove, so we keep that in mind. We don't have to keep flipping pages here. So I'm trying to show that the cosine of 2A is equal to 1 minus 2 times the sine squared of A. All right, so here we go. We're going to start in a different way. Okay, we cannot start out with cosine of 2A is equal to cosine of A plus A, because that's how we got the first double angle formula for cosine. Okay, this is a different double angle formula for cosine, so we're going to have to proceed in a slightly different way. All right, so I'm going to start with the cosine of 2A because that's what I have on the left side of this identity. Okay, well, remember what we just proved. Okay, we just proved that the cosine of 2A is the same thing as the cosine squared of A minus the sine squared of A. So I'm going to use that fact because I've already proven it. Okay, so the cosine of 2A is equal to the cosine squared of A minus the sine squared of A. Okay, so look at what my goal is. Okay, my goal on the right side here, the right side of this equation has only a sign. Okay, the cosines have disappeared. Okay, so what I'm going to do here is I'm going to replace this guy, this cosine squared of A. Okay, so I'm going to come up here. I'm going to put this in another color. We know the Pythagorean identities. Okay, like I said, we would be using these to do the derivations. Okay, we know from a while back that sine squared A plus cosine squared A has to equal 1. Okay, well, I want this guy. Okay, I want to get rid of cosine squared A. Well, I can solve this Pythagorean identity for the cosine squared of A. Just move over the sine squared of A. Okay, and we've seen this before. We know that cosine squared of A is 1 minus the sine squared of A. Okay, so I can replace what's in yellow with 1 minus the sine squared of A. Okay, and I'm going to do that. The cosine squared of A is equal to 1 minus the sine squared of A. Okay, so what's in yellow is equivalent. But I also have to tack on this other minus sine squared of A. Okay, so now I'm getting there, okay, because I'm in a position where the cosine squared, all the cosines have been eliminated, and I'm just left with sine terms. Okay, all right, so this 1, I'm just going to leave it there. But then I have minus sine squared A and another minus sine squared A. I can combine these guys, okay? I have, you're just going to add the numbers in front, -1, -1. You're going to have -2 of them, okay? So these guys will combine to be minus 2 times the sine squared of A if you combine them, okay? So we have proved the third formula, that the cosine of 2A is equal to 1 minus 2 times the sine squared of a. Okay, proven. Okay. All right, let's work on the derivation of formula 4. Okay, so I need to go get it. I forgot what it is. It is the last double angle formula for the cosine of 2a. Okay, so I'm going to write it over here. So let's go get it. Okay, so going back to my box, I've proved this one and I've proved this one. We're on formula 4 now. We're trying to show that the cosine of 2 times a is equal to 2 cosine squared of a minus 1. Okay, so I'm going to write this in the sideline here. We're trying to prove that the cosine of 2 times a is equal to 2 times the cosine squared of a minus 1. Okay, to get this formula, it's very similar to how we got the third formula. Okay, we are going to start off with the left side of the equation. We're trying to derive a formula for the cosine of 2 times a. Okay, we're going to use the information we had in the second derivation. Okay, in formula 2 that we derived earlier, we know that the cosine of 2 times a is equal to the cosine squared of a minus the sine squared of a. Okay, so I'm going to write that down. This is how we started the derivation of formula 3. And we're going to apply the Pythagorean identity. That sine squared a plus cosine squared of a has to equal 1. We're just going to apply it in a different way. Okay, this time, if you look at our goal, we want the right side to have only a cosine squared. Okay, we want the sine squared to be gone. Okay, so I'm going to go back up here in the margin. Okay, again, we know that sine squared of a plus the cosine squared of a has to equal 1. Okay, we want to solve this one for the sine squared of a because that's what we're trying to eliminate. Okay, so all I'm going to do is isolate this blue term. So I'm going to subtract cosine squared of a from both sides. And I'm going to get that the sine squared of a is equal to 1 minus the cosine squared of a. Okay, so I can go down to the equation where I'm doing my derivation, and wherever I see a sine squared of a, I'm going to replace it with 1 minus the cosine squared of a. Okay, let's do it. Okay, so I'm going to come down here. All right, I already know that the cosine of 2 times a is equal to the cosine squared of a minus the sine squared of a. I'm going to replace this blue guy. So I'm going to bring down the cosine squared of a. I'm going to bring down my minus sign, and then I'm going to replace the blue thing with its equivalent, okay, which is 1 minus the cosine squared of a. Okay, now it's got multiple terms. Okay, so I'm going to have to put this quantity in parentheses so that we come back and distribute the negative correctly. But the sine squared of a is 1 minus the cosine squared of a. Okay, and then in my next step, okay, and I'll highlight this, the sine squared of a, what's in blue, is equivalent. In my next step, I'm going to distribute the negative sign. Okay, so this is going to be cosine squared of a, distribute the negative, we're going to get minus 1, and then negative times negative will turn this into plus cosine squared of a. And then we can combine like terms. Okay, these two guys match. I have 1 cosine squared of a right here. I have another one right here. So I have 2 of them. So the green things will combine into 2 cosine squared of a. And then we'll just tack on the minus 1 at the end. And we have proved this identity. Okay, we have shown that the cosine of 2a is equal to 2 times the cosine squared of a minus 1. Okay, all right, one more to go. Okay, so we have proven the double angle formulas for sine and all 3 of them for cosine. The last guy we're going to derive is the formula for the tangent of 2 times a. Okay, so I'm going to go ahead and write this equation down on the next page, and then we'll see where it comes from. Okay, so out in the sideline, this time we're trying to prove that the tangent of 2a is equal to 2 times the tangent of A over 1 minus the tangent squared of A. Okay, so that is what we are trying to derive here. All right, to do this, okay, I'm going to start with the left side here. So the tangent of 2A, okay, and what is that equal to? Well, I'm going to start off, okay, with the method I used when I first proved the sine of 2A and the cosine of 2A identities. So the tangent of 2 times A is equal to the tangent of A plus A, okay? And then I'm going to apply my sum identity for tangent. Okay, so I'm going to write that out to the side here in red. We learned in the previous section that the tangent of A plus B is equal to the tangent of A plus the tangent of B divided by 1 minus the tangent of A times the tangent of B. Okay, so I'm going to apply this formula to what I have here. Instead of A and B being the arguments, we're just going to have both arguments be A. Okay, so tangent of A plus A is going to turn into the tangent of A plus the tangent of A over 1 minus the tangent of A times the tangent of A. All right, and now we can combine like terms in the numerator. Okay, in the numerator, I have a tangent of A and I'm adding another tangent of A. So I have a total of 2 tangents of A's. So that's going to be 2 times tangent of A over, in the bottom, I've got 1 minus, I'm multiplying tangent A by itself. I've got tangent of A times tangent of A, that's tangent squared of A. Okay, and that's the right side of the equation. Okay, so I'm trying to fit this in the same frame here. Okay, I have proved, if you look at the equation we were trying to prove, I have proved that the tangent of 2A is indeed 2 times the tangent of A over 1 minus the tangent squared of A. Okay, so that's it. Okay, I've shown you where all 5 of these double angle formulas come from, and now we're going to start doing various examples with them.